Tell those people that like
Do you have to blur our faces out? I'm gonna run in front of the camera a minute.
Thanks for voting for me. Yes, I'll give a shout out to that one person in Canada following. You rock.
I love you.
All right, so let's go through the directions here. Today we're learning about the shapes of molecules with covalent bonds. We're not doing ionic, just covalent. The name of this process or theory is called VSPER theory, which stands for valence shell electron pair repulsion, meaning that pairs of electrons try to get as far away from each other as possible. Okay? So, to find the geometry, the first thing we got to calculate is the steric number. The steric number is the number of the steric number is the number of atoms bonded to the central atom plus the number of lone pairs on the central atom. We'll be using pages 326 and 327 in the book, or Appendix G. Your choice. All right. So what the heck does that mean? Well, let's do an example together. Let's do boron tribromide.
We can't even see.
We need to do better with copy and stuff.
What's the one before
BBR3.
that?
MgCl2.
BBR3?
BBR3.
Is the O3 one just the 3?
Yep.
How many's are on B?
Starts with 3. It wants 6.
Why are you doing this so quickly?
We're doing the Lewis dot structure. That's the first thing we do. This process actually becomes pretty simple once you understand what we're doing.
Just take some.
So, who's the central atom in this Lewis dot structure, Nicole? Boron. Now, how many atoms, Nicole, sorry, not Nicole, Nikki, how many atoms are bonded to that boron? 3. Now, how many lone pairs are on that boron? A lone pair would be something like this. 2 electrons by themselves. We don't have anything like that, right? All the electrons are paired up. So there are no lone pairs.
Will there be sometimes?
Yes. And then the steric number is the addition of these two columns. The number of atoms and the number of lone pairs gives me the steric number.
Well, you ever have a negative number?
Never.
For the bonds, if it was like a double bond, then would you say 4 or what would you
Nope. It's just the number of atoms and the number of lone pairs. The number of bonds, whether single, double, or triple, doesn't matter.
say? Okay.
Now for the hybridization here, Allison, we go to our little chart here. A steric number of 3 gives me sp2 hybridization. Now we have to draw the shape of the molecule. And there are a number of different ways you can draw the shape. There's one way you draw it on Appendix G. You can draw them like you see in the book on page 326, 327. And there's even another way to draw it, which I'm going to show you. But first we should probably identify the shape. So these numbers are the steric numbers. And we said we had an SN of 3, right? So we're in this row. We have 2 options for our answer. Trigonal or angular. Dots are atoms. So this one has 1, 2, 3 atoms, no lone pairs. This one has 2 dots, or 2 atoms, and 1 lone pair. So which one is it? Trigonal or angular? Trigonal. So we could draw that picture there if we wanted to.
Should we write trigonal?
Yep, we will be in a second. So you could draw that picture if you wanted to, or you could draw the picture in the book, or you could draw it like I am going to draw it right now.
Which way is easier to decode?
They all have their pluses and minuses. Because you see, a trigonal molecule looks like this.
You just draw that.
So how do you draw this on a two-dimensional piece of paper? Well, one way you can do it is draw the molecule this way, where one of the things is coming out at you, one of them is coming back at you, and one of them is going like this. To draw it like that, with this configuration, to show that one of them is coming out at you, you do a little triangular wedge, like that. And then behind it, you do a little slashed triangular wedge, meaning it's going away from you, and a solid line means it's in the plane.
Can we just write this one?
Or you can draw the one that's in
I feel like
Appendix
easier
G.
to- how
That's
do we-
fine.
How do we know that though? Like how do we know?
I'm
for-
trying to teach this to you. That's why.
How do you do it for like more than?
You can do it for more than one thing.
Why can't you just draw it? We can draw it again.
What are the like scientists?
They use all of them. It all depends on what they want to show.
Is that if we do different ones for like?
Yeah, you can do whatever. They all have their pluses and minuses. Sometimes you want to show this, sometimes you want to show something differently. The angle between the two atoms is 120.
Do you
Right.
have to write that?
I want you to show me the bond angles when possible. Okay? You should be able to calculate that bond angle.
Oh, they meet.
Because you know a circle's 360 and you have 3 atoms, so
They're all gonna be equal.
for the ones that you can figure out, yes. The name of the molecule was trigonal. And then the last thing we want to find out here, Mariah, is it polar or nonpolar? If it is symmetrical, it is nonpolar. If it's asymmetrical, then it is polar. So nonpolar is symmetrical, asymmetrical is polar.
What's asymmetrical again?
Asymmetrical means no symmetry. And you determine that by looking at the bond lengths, the bond axes. So I take my little thing here, and I chop it along the toothpicks, the bond lengths. Is that symmetrical?
Yes.
Yes. How about that bond length?
Yes.
How about the last toothpick? Is that symmetrical? Yes. So if it's symmetrical along every toothpick, then it is symmetrical, and therefore it is nonpolar. Now, why do I care about the polarity? If you know the polarity, I can automatically tell you some things about this molecule. It'll be a gas, it will be non-conductive, it will have low melting and boiling points. So the whole idea of learning the Lewis dot is so that we can predict the shape, and from the shape we can predict the properties. So anything that's nonpolar, it's most likely going to be a gas and non-conductive.
I have a question.
Yep.
So when it says identify central atom, what if there isn't a central atom? Because there's only two. Yeah, I was gonna.
Oh, we haven't done one of those yet. We will. But if there is no central atom, you just get to pick one. doesn't matter which one you pick. So any questions
I have
on
one.
this one? Is it on this one?
Yeah.
Okay, yep.
If you draw it a different way, where would you put the 120 angle?
Well, it depends how you drew it.
Like I drew it how this one draws it.
Then just write it in there, in the middle there.
Wherever.
Well, in the angle. So like, I would just put my angle like, boop, 120. Any other questions? All right, let's try one with only 2 atoms in it. Let's try SO. Sulfur oxide. So if there are 2 atoms, it doesn't matter which one's the central atom. So Max, just pick one for me. Okay. How many atoms are bonded to the sulfur? How many atoms?
4.
There are 4
Oh,
atoms
1.
attached to that.
I was counting electrons.
Wait, I don't get that.
There's only 1 atom, that oxygen, attached to that sulfur. Counting atoms, not electrons. How many lone pairs
4.
on the central atom?
2.
What is the SN? 3.
So it's the same as 1 2.
And the hybridization would be
SP2.
SP2, which it better be, because we just learned yesterday that when you have a double bond, what's the hybridization? SP2. I got a double bond, I better have SP2 hybridization.
Should we draw the line structure too?
These would be
Well, oh no, you don't need to, I just, shape.
Okay. So this.
There are only 2 atoms. 2 points make a line. So that's it.
There's no degrees.
Well, I guess they'd be 180 from each other, but
Do you make those dotted lines or not?
no, you don't need to make dotted lines.
But like the picture they show is like 2 atoms.
There's no picture of this on your Appendix G.
Then how do you know?
Because, Hannah, 2 dots will make a line. That's the only shape it can make.
Okay.
So all SP2s are like that?
Nope, just that one.
Alright.
Will you be here tomorrow?
Yeah.
Okay. Yes, Nikki. Okay. What's the name of this thing? It forms a line, so let's call it linear. Is it polar or non-polar?
Non-polar.
Now, when you're dealing with 2 atoms, there's a different way of checking for polarity, and it's just for 2 atoms. When it's 2 atoms, you check for polarity by doing the electronegativity difference. Oxygen is 3.50. That's right, I have it memorized, Bushik. I've reached a new level of geekness. Sulfur is 2.44. I do the subtraction and I get 1.06. So when you're dealing with 2 atoms, Jordan, do the electronegativity difference. Then, if it's greater than 1.7, it's ionic, but it's not. Plus I told you there's nothing on this worksheet that's ionic. If it's between 0.4 and 1.7, you have a polar bond, also called polar covalent. If it's below 0.4, then it would be nonpolar.
That's only for 2 atoms?
You only do this when it's 2 atoms. So this thing is 1.06, so it would be polar.
You don't get any anionic ones on the other.
There are no ionic ones on this. And you only do that electronegativity difference, Brad, when there are 2 atoms.
Do you have a partner?
You will have a partner on this. Yes, Hannah.
I just have a question of how you've got the number of atoms bonded to the central atom.
Yep.
Why isn't it 2 low?
For this one,
Yeah.
the number of atoms. So Max picked sulfur to be my central atom. There's only 1 oxygen bonded to that sulfur.
Oh, okay, that's all you do?
That's all you do. Let's see. There's one other thing I was going to say here. Oh, so I just want to say that polar and nonpolar, they're both covalent bonds, which means you're sharing these electrons right here. Okay, you're still sharing, but the sharing is unequal. If you're a polar covalent, the electrons spend more time with the oxygen than they do with the sulfur. If it was nonpolar, they would share equal time around the atoms. Okay? Ionic means that it's so strong the electrons are ripped off one atom and stolen by the other one. Okay? Another way I like to think of this, Jeremy, is like dating. Okay? Ionic, that's where you paid for the dinner, you paid for the movie, you paid for the Cold Stone ice cream, you paid for the flowers.
And they dump you.
That's right. 80 bucks out the window, ionic. Polar covalent, that's where you pay for dinner, you pay for movie, she pays for the Cold Stone ice cream. There's still some sharing going on, okay? It's not complete sharing, but there's some sharing. And then non-polar covalent is where you split it right down the middle. Split the dinner, you split the movie, split the Cold Stone, and you buy each other flowers. All right, any other questions on this one? Before we do one more example, then I'll turn you loose.
Yeah. No, not on that one, but in general.
Okay, how about we do good old-fashioned H2O. You know they invented dehydrated water?
What? For what?
You can buy it online.
You can buy it online, yeah, dehydrated water.
What is it for?
Well, just in case you're on the desert, you can carry some dehydrated water with you.
They just have to
Is
add
it
water.
like dust?
You just like measure out a half a cup of it and then just add water and you're set.
That's not, it's you're done.
Yeah.
I still don't get
I
the
don't get it.
There's not a joke, but I'll sell you some.
Yeah.
For a little month.
Lots of money because it's really expensive to make dehydrated water.
Why would you want it though?
So if you're in a desert and you need water, all you gotta do is add some water and you'll be set.
Haha, I laughed. It's stuck.
All right, there's the Lewis dot structure. Who's the central atom, Katie? And how many atoms are bonded to that oxygen, Hannah?
2.
2.
Or,
Yep. And now, what about the lone pairs?
2.
There's a lone pair. There's a lone pair. So we have 2 lone pairs.
Do you circle them like that?
No, I was just trying to point them out to people. So my SN number is going to be what, Luke?
4.
4. Now, if you're astute, you probably picked up on the fact that you can figure out the steric number just by adding up the orbitals.
S1, P3, that equals 4.
So S1P3, yep, equals 4. So your hybridization would be SP3.
You write that clear.
So 1s orbital and 3p orbitals equals 4, which is what your steric number is. If your steric number was 6, what would your hybridization be if your steric number was 6?
S1,
B3,
P3,
D2.
D2.
D2, really? Oh, okay.
Now it clicks.
Yeah.
Otherwise, you can still look at this chart. Still look at that.
Well, it's just saying that you don't have to use that.
Shape of the molecule. All right, so hybridization, sp3. It's going to be one of these three types: tetrahedral, pyramidal, or angular. So we're looking for something that has 2 atoms and 2 lone pairs. So yes, angular would be the name and the shape. So let's draw it for our British friends out there following us.
I forgot your British name.
How do you know this polar,
We got to build the molecule.
What is that circle thing?
Whoa, whoa, whoa.
Those are my lone pairs of electrons.
Are we? Do we have to? Sorry.
Sometimes they'll be called bent. So angular and bent mean the same thing. Now, how do you know if it's polar or nonpolar? You really do have to build the molecule and then look for symmetry.
If we don't know how, then we don't know.
You'll learn. So, I have 4 atoms.
3 atoms.
Going around my central atom. If I had 4 atoms going around my central atom, what would be the angle between my 2 atoms? 90. Now, remember, the name of this theory is valence shell electron pair repulsion. The atoms want to get as far away from each other as possible. So they repel each other, and right now they're only 90 degrees apart. They can actually get farther if they move themselves into different planes. So now that angle becomes bigger. And that angle is actually 109.5 degrees.
Should we write it down?
No. Now what happens though when I have 2 lone pairs? 2 lone pairs would just be two toothpicks. So you have 2 electrons here, you have 2 electrons there. They're going to repel each other and push the atoms slightly closer together. So that angle of 109.5 shrinks down to 104.5. Not that you would know that, nor do I expect you to know that, but I wanted to just give you an example of how that lone pair causes a change in the shape. And this angle becomes very important when water freezes. Because you have this angle and those 2 lone pairs, when water freezes, it is less dense than the solid. Less dense than the liquid. Because ice is a solid, right? Last time I checked.
Where?
As far as I know, H2O is the only substance in the universe where the solid is more dense. Solid is less dense than the liquid. So if you throw ice on water, it floats. But if you take solid iron and you throw it into a pool of liquid iron, the solid iron sinks. If you throw solid copper into a pool of liquid copper, solid copper sinks. But if you throw solid H2O into a pool of liquid H2O, it floats. Ice cube. Yep. So, okay, let's take a look at the polarity. Let's chop it along a bond length. Is that symmetrical? Yes. How about this bond length? Yep. How about this bond length? No. As long as you can find one plane of asymmetry, the whole molecule is polar. Polar substances will be liquids. They will have moderately high boiling points and melting points. And they will be slightly conductive. Okay?
Partners? The bigger partners?
Not yet. Now, all of these follow the rules you have on Appendix F and G. When it says NA, it means not applicable, so you just skip that box and move on to the next box. And all of these follow the rules laid out, like I said, on Appendix F and G, except for there are a couple that are very, very strange.
When it's not applicable,
You just skip the box,
but how can you know how to draw it?
because it's just two, and two dots make a line.
Oh, okay.
For sulfur, tetrachloride, for chlorine trifluoride, and xenon difluoride, the central atom is going to follow the rule of 10. Normally, sulfur wants to follow the rule of 8 or the rule of 12, but in this case, put 10 around the sulfur. Get 10 around the chlorine. Get 10 around the xenon.
Can you go to this page and just tell us what the letters are?
Just a second. And then the other two that won't follow the rules are iodide pentafluoride, get 12 around the iodide. Or xenon tetrafluoride, get 12 around that xenon. Everything else will follow the rules correctly. But those two on this page will not.
And what were the other ones? These two
And then on the previous page,
yeah.
those guys are all going to follow the rule of 10. Everything else will follow the correct rules.